Thanks for inviting me out. I'm really happy to be here to interact with so many interesting people, both in person and online. I'm going to talk a bit about something I do with my future elementary teachers. I teach a class at Red Deer Polytechnic. Yes, that is a real institution, and we just started offering degrees recently. I just joined 2 years ago. Here's our cool logo made by our welding shop. It's an interesting institution because it's a polytechnic. So we train nurses, teachers, but also welders and a variety of people. So it's an interesting place to be. What I want you to do, all of you, even you in person, just open this presentation. I put a shortened URL down here, okay? So bit.ly/3, this is an O, not a 0. So it's a capital O, 3 capital O, I, small o, capital T, PY. So just give you a moment to pull that up. There's an aspect of participation here, so yeah.
I, small o, big T.
You're done.
Good.
Oh, there we go. Thanks, Gary. Yeah, you can just click on Gary's link in the chat.
Everybody's there.
Okay, everyone's got it. All right. So we're going to start with an activity here. So I just want you to put your salary on the following scale. Okay, so you can physically click on this scale, and it will take you to a Jamboard. Okay, and you can just draw it, but don't do it yet. Let me just say go, because I don't want people to see what other people are putting. Okay, so just get to this Jamboard now. Pull up your pen. You should be able to write. I just did. Okay, so now that everyone's there, I just want you to put your vertical tick where your salary is, your current salary. Just put it on that scale, okay? Everybody can go and do that, including everyone online. Yeah, I'll have to do it really quickly, okay? So you're not influenced by everyone else. Just put a tick where your salary is.
Well, no, it doesn't work.
Oh,
Oh no, don't move my. Okay. Oh my. Let's move that back. Somebody here. Just don't touch the overall thing. Just select the pen on the side here. Like that. And then just put your no, stop moving that.
There it is.
Whoever that is, stop moving my background. No, stop touching the background. Gosh, is one of my kids on the call here? Okay, just select the pen here on the side, on the left,
Okay.
the top, and then just put your salary there. There we go. Nice bold line.
That's nice.
Select the pen on the left. I should be seeing, well, 16. Should be seeing 18 marks down there. I think only 3 or 4 of you have done it so far. We got a postdoc responded negative, or maybe
good.
that yellow mark at 0. That's about a postdoc salary, right?
Not at Ontario Tech.
Great. So we're getting some ticks in there.
Oh, it's here there. Ah, I see.
Interesting.
Okay. Well.
Very good. You get the idea here.
So I get the
Couple $1 million.
Couple $1 million, see? Gotta come to Toronto, that's where the money is.
There you go.
In education. Great, so it's, you all have an idea of how this should go, so it's hard to pull the wool over your eyes. But when you run this with students, where do you see the cloud of ticks? I usually tell my future students, okay, where's your salary as a future teacher going to be on this scale? And they usually put it, roughly around here. Right? And there's usually a cloud of tick marks all around this area. But let's unpack what it is. So I didn't start it at 0 on this side. I put it at 1,000 up to 1 billion. Okay, but 1,000 relative to 1 billion, it may as well be 0. So we can imagine that this is a $500 million here, so 500 million. And then if I cut it in half again, we're already at 250 million. So these students really think they're gonna have it made as teachers.
Yep.
Right? But even some of you, I really don't believe that professors make this much in Ontario. I certainly don't. But that's 125 million. So this is roughly $67.5 million right here.
Yeah.
Okay.
That's
And so on, and you can explore it like this. Really, and I mean, I don't want to speak for you all, but I assume that pretty much all of us, our salaries are indistinguishable from the left endpoint.
That's right.
Right? That we're so close to 1,000, you can't tell our salaries apart from 1,000. Okay, let's go back to the presentation. So it's a nice little example I learned from this researcher, David Landy in the States, a psychologist who looks at number perception. And sure enough, humans are really terrible at large quantities, at understanding large quantities, okay? We're fairly good at understanding up to 1,000 or so, maybe even 10,000, 100,000, maybe even up to 1 million. Because 1 million's not ridiculous, it's kind of within reach of our salaries. It's, an order of magnitude larger than our salaries. So it's something that we can kind of have a feel for. But then you go to 1 billion, even the people in this room have no idea what that is relative to these smaller numbers. It's a very difficult thing to grasp, these bigger numbers. Okay, and what I want to argue, so part of the theme for today is math and social issues. What I want to argue is that this kind of inability to grasp large numbers is a contributing factor to a lot of the problems, contemporary problems we see in the world today. Okay? Many of the things that we deal with involve large numbers. Okay? We see absolutely insane net worths of the tech giants. Okay, $223.2 billion. How much is that, right? How many University of Toronto students tuition could Elon Musk pay, and for how long? Okay. We see it in climate change. Climate change is something that acts on a larger scale. Okay? We have no appreciation for that scale because I would argue the numbers that are involved are larger than what we are capable of perceiving and understanding. Even things like science denialism, where we have people still protesting evolution. Evolution, again, is a large number game, that things accumulate over large scales of time. And we're talking like massive number of mutations and all this. So to me, fundamentally, it's about large numbers and perceiving large numbers. Here's a nice little example. Little example here from this author. You've probably seen this one before. 1 million seconds is 11.5 days. 1 billion seconds is 31 3/4 years. Okay, so it throws things into perspective. The research from David Landy, he finds that people tend to space equally 1 million, 1 billion, and 1 trillion, partly because it kind of rolls off the tongue. They sound similar, but they're not at all comparable. But they put them in a linear order because they feel like that is the scale that we're working at. Okay. Great. So I'm gonna just talk a bit about how we might get students to understand these large numbers of things I've done in my classroom. But then I want your input on how else you might do this. Okay, so I should have some links here. So this is a slide from my class for future teachers, where we talk about Jeff Bezos. So he had roughly a net worth of about $200 billion. Then I have these questions. How long would an elementary school teacher in the Edmonton Public School Board need to work to make Jeff Bezos' net worth? So they would have to research what the starting salary is, for example. It's about $60,000 for a teacher in EPS. Okay. Any ideas how long they would need to work? Do you want to work that out quickly? How long would a teacher need to work in order to make that? Give it a shot. Do a little rough calculation.
It could be dead before they earn their money.
300,000-ish years. That's scary.
300,000-ish years. It's probably nowhere near where it should be. I believe, I forget what the number is, but it's longer than the Earth has been around. So, it puts things into perspective. 200 billion isn't 200 million. It's another thing entirely that we can't just readily compare, okay? So this is one way we could do it to start to understand these large numbers, is relate them to things that you're very familiar with, that you're invested in, or that you have a personal relationship with. Okay. We could also flip the discussion and say, how long would Jeff Bezos have to work in order to make as much as a teacher? Supposing that, his net worth, or he makes a certain amount per year. I said he makes 7 billion a year, which I just got by dividing 200 billion by 27 years, which is how long he's been out of this game. How long would he have to work? Any ideas? You want to take a guess? Something like 3 seconds. So it gives you an idea, right? It starts allowing you to understand these types of large numbers. Okay. Let's pick on Jeff Bezos a little more. I think he deserves it. I think he's been picking on us a bit. So wealth shown to scale. This is a nice little website. Let's just dive right in. Okay, so on this website, that little pixel there is $1,000. Okay, and so this is $68,000. This is $1 million. And then this is $1 billion. Okay. And so here is Jeff Bezos' net worth, $185 billion. And in case you're wondering, I am indeed scrolling. The scale is moving. We'll just scroll through his wealth here just a sec. I'm doing this for dramatic purposes. It's just a slow scrolling. Where's the here? So you can, this thing hardly has moved. So it's quite unimaginable, sure. Let's just physically scroll down here. This little sentence here, it says, we rarely see wealth inequality represented to scale. This is part of the reason why Americans consistently underestimate the relative wealth of the super rich. I would argue it's not just Americans that do this. Every pixel you scroll is $5 million. Okay, we're coming up to the end now. Great, so I'll just scroll from this. Coming up to the end now. There's gotta be an end in sight. They promised us.
Well, the end can be long.
Lol, just kidding. We're about a third of the way there.
Oh,
So this website's nice. I'm trying to make the point here that we can also relate that wealth to time. Okay, so you can physically scroll through his wealth and you can feel just how painful it is to watch me stand up here and just scroll and scroll. It takes time to do that. And you get an appreciation for it. And they do all sorts of, it's a really neat website. They do all sorts of different comparisons here. And they talk about, you know, the annual cost of housing every homeless veteran that fits in there comfortably. The annual cost of chemotherapy for all cancer patients in the United States. That fits within there comfortably as well. Okay. So, difficult to imagine, but I think we can come up with ways for our students to understand it a little better. I have another task here on the side, which I've done in class. And you have the moon, perhaps you represent it as a quarter. Then you can ask, well, how big should the earth be relative to that quarter moon? And then they, you know, create an earth, a little earth disk out of paper or something. And then they get to kind of guess where they belong relative to each other at the front of the room. And so I'll put down one of the earths and every student will get a quarter and then they have to place it. And just like with the salary scale at the start, no one's near where it needs to be, right? Because it is a large distance and it's difficult to get an appreciation for that. Okay. Now I'll just turn it over to you because I've said too much already. Do you have any other ideas of how we can get our students to understand large numbers? Maybe not just students, but maybe the public, maybe people in general. Okay, so talk with a neighbor for a minute or two, and then I'll solicit some ideas. And those online, you're welcome to write in the chat some ideas here.
time, space, what else?
You're coming over.
Yeah, I'm coming over. Yeah, how are you doing? Good. No bad. And getting people to understand that.
So far? Yes.
Yes, I don't know.
This reminds me of a problem that I like
I would suggest that it depends on, especially these things we're talking about, adult learners, right? Students.
You have a glass of water here.
I think,
In 16 something, Queen Elizabeth had the same glass of water on her table. What are the chances that one of the molecules in her glass is now in my
one thing.
And so you have to assume that she drank that water, that it now is mixing randomly with all the water.
Modeling in Excel.
So
We know,
assume
and I know that the
all the water
codes
based.
are limited anyway, but then nonetheless, there's a minimum.
And
Science, you can look it up on your special. And I would suggest that in this case, an activity like this,
so
you
of course,
could try
a large number of molecules,
model
and that's surprising.
how many of the rows in the Excel spreadsheet would fit within the interval of say $1,000 to $1 billion, right? You can easily model that and have the count of the number of rows,
There are thousands of molecules
because that,
in here.
because it's a finite number of
Do that,
rows,
it gets
right?
them,
It's easier for them
because the numbers are so
having
big.
of the rows between less than 1,000, and then the
No,
because what you would do there and is
How many rows are there in Excel?
that's a good question. Yeah, that's a good question.
Okay, I'm gonna solicit some ideas here, so just wrap up your discussions.
Yes, so quickly.
Things like that, because I believe they teach them.
So if you say and go.
It sounds like, yeah. Something, yeah. Or you don't have to.
Numbers comprehend what they mean.
Yeah.
Don't necessarily. expect
Template
that.
like.
Maybe.
That is.
Okay, any other ideas of, you know, it's. I think understand isn't the right word here,
Okay,
because we understand that there's large numbers there.
usually if you put.
But it's more of getting like an appreciation of just the relative sizes of some of these numbers, okay? So how else might we do this?
I have a
Yeah.
question, and if it's all right.
Yeah,
Do you think it is possible for us to grasp
yeah.
these numbers?
So this
Is
is the question here, because I don't think people online can hear you. The question is.
They should be able to, because we have mic.
Oh, okay.
These
I'll
are
just
the
repeat it,
nights.
it's fine.
Yeah.
Is it even possible to understand these numbers or to appreciate these numbers? I would argue no, that it's not innately possible, but that's why we develop mathematics as a tool, because we, you know, for example, we talk about subitizing and like distinguishing sizes, small sizes of dots, fields of dots, and like doing snap judgments on which one's larger and this and that. And that's innate. But as soon as those groups of dots get slightly larger, not even that big, just around 10 or so. So if I have a field of dots, 10 here and 11 here, students struggle in creating a snap reaction to which one's bigger. So that's where we reach our limits in terms of number sense, like innate number sense, I think. So then we have to develop these tools to grasp anything larger than that. The interesting thing in one of those David Landy papers he was talking about, you know, students don't struggle with seeing the difference between 2 and 5 in terms of like the magnitude of that difference, but they do struggle seeing the difference between 62 and 65. Like somehow that registers different to students. Okay. All right, so ideas of how we might understand large numbers. Geometry, yes. In what way?
Well, you gave an example with dots to represent number, but I think in time, scrolling through that long rectangle of money,
Mhm.
spatial visual sense of proportion and distance.
Mhm. Yeah, geometry is nice. There's a children's book that I came across. I think it's called 1 Million Dots, and it really is just 1 million dots. But they tried to put that in context. What does that actually mean? And you have to like, flip through this book. I remember I cut out a large section of it because it just went on for way too long at bedtime. But it gives you a sense of how big these numbers are. Okay. Any other comments for now? I have one last activity.
Go ahead.
No, okay. I didn't see what time we started, so
You're okay.
I will,
We're
okay,
gonna-
we'll wrap it up right. So here is another task that I'm working on. I'll probably give it to my students next week, okay? Because the title of the talk, of course, is the inequality of numbers. And what I mean by that is exactly this, that I think, you know, society is becoming more unequal, perhaps reverting back to previous times of inequality. And that's difficult to understand. We've got a lot of billionaires around, and we're not quite sure what that means, billionaires and things like this. And so we want to start describing inequality present in a country, let's say. Okay, so I've set it up here. I'm not entirely sure how to word this in a way that students can understand it. So you're welcome to read it and see what we can do with it. Okay, so I have on the final page, which you should be, yeah, you can click on and it will bring you to a Jamboard version of this. I've got this graph here. It's got proportion of population at the bottom, proportion of wealth, and then I talk about percentages here. Anyhow, what I'm trying to get at is graphing inequality. So I've got my first question. In a perfectly financially equal society, what percentage X of the population owns percentage Y of the wealth of the society? draw that distribution curve for this financially equal society. Okay. Oh, actually, you know what? People can do that if you want to go here. See if anyone's done it. Again, make sure you select the pen. I think Jamboard is not very good in that. I don't think you can draw a perfectly straight line. Great. Whoever that icon is, thank you. So in a perfectly financially equal society, we should see, you know, the first 10% of the population owns about 10% of the wealth. You know, 50% of the population owns 50% of the wealth, and so on. Then I give you a little data here. I couldn't find data from both Canada and USA that use the same increment. Okay? But it gives you an idea. In Canada, the first 20% of income earners in the country own about 7.1% of the wealth. Okay. Then the next 20% owns 13.5%, the next 20%, 17.5%, and so on. Okay. Then the upper 20% owns 39% of the wealth. Then I've got the USA numbers down here. I wasn't surprised so much about this. You know, I lived in Silicon Valley and there's a lot of money down there. I was a little more surprised by this, that the first 40%, or from 0 to 49%, I should say, that range of percentage of the income earners in the USA own only about 2.6% of the wealth of the country, which is really not that.
But it's a 200 million or billion, right?
Yeah, this is true. So the idea here would be to start plotting these types of things, okay? And why don't you do that just roughly right now? Even if you have a sheet of paper, what would those two curves look like? You know, and it doesn't have to be exact, but just generate some curves for yourself. One for Canada, one for the USA. And whoever's working on the Jamboard, I'll let you draw that. I'll just give you 30 seconds or so.
So, well,
Yeah, so pick whoever's drawing online. Maybe just label your graphs. The two of you can collaborate. Or pick two different colors, for one for Canada and one for USA. One minute left. Yeah, okay, good, perfect.
And then that's 7%.
Yeah.
And then almost doubled.
You might want to pick 3 colors for the USA, red, white, and blue. They're all about that down there.
because that's,
And the 17.
some of the two is 20.
And maybe
Yeah.
label your graph
And
as
the
well, like that red
60,
one,
it's like
is that
17.
USA or?
Another 20.
Not that much.
Okay, we'll have to settle with BSA. Oh, there we go. Great, now let's just draw Canada.
%40. Wow, it's about there.
Canada's out there in the wilderness.
Something.
Can we create, there we go.
So it's.
Try creating a curve quickly for Canada.
That's a good
Cycloid.
exercise.
That's cycloid.
Sorry,
This is.
cycloid? Cycloid is a precise, who knows? I mean,
Might be.
it's an exponential curve is what it is. Because it's kind of,
Yeah, technically these are called Lorenz curves. I think he was an Italian communist.
oh,
And I think they're not exponential, you can get a functional form. They're out there. Okay. So roughly, I don't know, roughly we have for Canada. Just do it really here, I'll do it, oh no, just go for it, just be bold. Go, just go, go, go.
You can do it.
Okay, I'll just help them out here. All right, here we go. Canada, right there. So which of the two are is the more unequal, financially unequal society? Which would you say? Specifically referring to the graph. Which one between Canada and the USA is more financially unequal? So Pam says the USA. Now, why? What about the graph makes you think that? Anyone can chime in.
So we'd expect it more equal, it would approximate that equal line.
Right, it should be hugging the equality, the line of equality here, that diagonal. Okay, so somehow the further away from that you are, the more unequal your society is. Okay, how could we describe that? How far away you are? Any ideas? Because potentially these don't have very nice representations in terms of like a closed form or an equation or something like that. So how might we describe that? How far away from the line of equality? Any ideas? Gary's got a great suggestion here, area under the curve. Okay. So how exactly could we fold in area under the curve here? Yeah, perhaps something like this, difference between lowest and highest. So perhaps if we look at a perfectly equal society would have, an area of 1/2 under this curve, let's say, right? Because this is, I just have it going up to 1 on the scale. Okay? So this should be 1/2. Then you could calculate the area under this curve. And you could perhaps look at the ratio or how far that deviates from that perfectly equal curve. In fact, that's what people have done. This is, not to let the cat out of the bag, that's the title of my Jamboard, is the Gini coefficient. Do you pronounce it like this? This is the Gini coefficient, exactly that you're looking at the ratio of those two areas, okay? So then the lower the Gini coefficient your country has, the further your country's wealth curve, Lorentz curve, is away from that diagonal. Okay, so this is one way of capturing really what amounts to really large numbers. We're trying to kind of control them, bring them down, and relate them to things that we can understand easily. Okay, that was it for me. I actually don't have a concluding slide. I didn't know who was going to be here, so it was a pretty interesting discussion. Any questions for me? I welcome interactions over this later because I think it's important, like Peter was saying earlier, that the action is really in elementary school. That's where we ought to be reaching these teachers.
Absolutely.
Right, and really strengthening the education we offer teachers so that they can in turn influence quite a few students later on. We also know that elementary school math teaching matters a whole lot, that it can change the path students are on, can steer them away from math for years. So we want to make sure we strengthen that. And not only that, what I mean by that, strengthening our elementary education or education for elementary teachers is really to dive into topics like this so that they end up with a deep appreciation of number and really can pass that kind of intuition they develop onto their students. Okay.
Thank you so much, Wes.
Thank you.